Right now, a fleet of NASA spacecraft are turning their attention to an unusual object speeding through our solar system.
It was supposed to move, but one night it didn't. When NASA's tracking systems froze midstream, scientists stared in disbelief. 3I Atlas, the third interstellar object ever found, had been racing through space at incredible speed, then suddenly appeared motionless against the stars. No flare, no explosion, just silence. For hours, its position stayed the same, as if time itself had stopped. Across observatories, data confirmed the impossible. The object had stopped moving. Was it a glitch, a natural phenomenon, or something entirely new? Whatever it was, that single pause would change everything we thought we knew about motion in the universe. Before that night, 3I Atlas was just another strange visitor passing through our solar system. Astronomers had tracked it for months as it moved steadily closer to the sun, glowing faintly but behaving like any other comet. Its path was perfectly hyperbolic, meaning gravity would never capture it. It came from far beyond the Oort cloud, traveling millions of miles across the void, carrying the chemical fingerprints of another world. No one expected it to stay long. Objects like this come and go, leaving behind nothing more than dust and questions. But 3I Atlas was different. From the moment it entered the heliosphere, its light flickered in a strange rhythm. Spectrometers detected high levels of carbon dioxide mixed with traces of nickel and water vapor, an odd combination not seen in any known comet. It was as if the object had preserved ancient chemistry from a colder, darker system that predated our Sun. At the Keck Observatory in Hawaii, astronomers noticed that its tail wasn't behaving normally. Instead of curving away from the Sun, some of its material seemed to bend toward it, as if responding to another force. Still, most scientists wrote it off as an optical trick, a small irregularity in a chaotic, unpredictable traveler. Then came the final approach. By early spring, the object was moving faster than 37,000 miles per hour and shining bright enough to be seen even through the glare of the inner solar system. Ground-based observatories in Chile and the European Space Agency's satellites followed every move, feeding live telemetry back to NASA's Deep Space Network. Every reading confirmed the same thing. This was a normal comet on a hyperbolic path, until the data stopped changing. That night, the feed froze. The comet's position no longer shifted relative to the background stars. Astronomers checked everything tracking alignment, exposure, timestamps, but all instruments agreed. 3I Atlas had stopped. For the first time in recorded history, an interstellar object appeared motionless in space. Phones rang across observatories, emails flooded in, and within hours, NASA's Jet Propulsion Laboratory called for an emergency review. The world's most powerful telescopes turned their eyes toward a single point of light that refused to move. And the longer it stayed still, the more it defied reason. What made this pause so disturbing was that motion is the foundation of the universe. Planets orbit, stars spin, and comets race through space without rest. To see one stop was like watching the heartbeat of the cosmos skip a beat. Some researchers whispered that maybe this was no comet at all, but something older, more deliberate. Others warned against jumping to conclusions. But the fact remained, the cosmos had gone still, and no one knew why. If the visitor had truly frozen in place, what force could be strong enough to hold it there? That question would soon ignite one of the biggest scientific debates NASA had ever faced. The discovery came quietly, almost by accident. At first, astronomers thought their tracking software had failed. A pixel that should have been shifting across the star field remained frozen. But when other observatories confirmed the same thing, disbelief turned to alarm. The object known as 3I Atlas was no longer moving. For hours it hung in the same position, glowing faintly against the dark. Telescopes in Chile, Hawaii, and Spain all recorded identical readings. The stars behind it drifted, the background shifted, but the object itself stayed locked in place. Inside NASA's Jet Propulsion Laboratory, the atmosphere changed from curiosity to tension. Scientists huddled around live feeds, watching a silent point of light that defied every rule of motion. Some thought it was a glitch in timestamps or exposure settings. Others believed a cosmic alignment had created an illusion. But the deeper they checked, the clearer it became. Nothing was wrong with the equipment. 3i Atlas itself was doing something impossible. That realization sent shockwaves through the astronomical community. Objects from outside our solar system are supposed to move fast and unpredictably. They follow the sun's pull, loop once, and vanish back into interstellar space. Yet this one had stopped mid-flight, like a clock that refused to tick. Engineers recalibrated telescopes, reanalyzed data, and compared measurements across continents. Every test led to the same conclusion. The object's coordinates had not shifted by even a fraction of a degree. In science, motion is everything. The universe breathes through movement, planets spin, stars orbit, galaxies expand. To see motion vanish is to question the foundation of cosmic law. One astronomer described the moment as watching gravity lose its grip. Others admitted they felt a chill, as though something beyond comprehension had paused the cosmos itself. While cameras continued to capture the eerie stillness, strange details emerged. The brightness of the object pulsed softly like a slow heartbeat. Its tail flickered, then dimmed completely, leaving only the nucleus visible. Spectral data revealed no violent outburst, no energy spike, no debris. It wasn't breaking apart. It was simply still. By dawn, news had spread across research centers worldwide. Private observatories, universities, even amateur astronomers confirmed the same result. A foreign object, tens of thousands of miles wide, had frozen in the void. NASA scientists avoided public statements, choosing to analyze quietly while speculation flooded the internet. People wondered if the comet had hit an invisible barrier, or if space itself had shifted around it. Others whispered darker theories that the object might be reacting to something or someone watching it. Whatever the truth was, one fact stood unshaken. Motion had ceased, and the laws of physics stood still with it. If an interstellar traveler could stop in mid-space, what else might it be capable of? That was the question echoing through every control room as dawn broke across Earth. When the data first reached NASA, confusion turned into urgency. Dozens of astronomers stayed up through the night, staring at motionless graphs and static star maps that made no sense. The reports from Chile, Hawaii, and Spain all matched perfectly, confirming that 3i Atlas had stopped for real. No system error, no software malfunction, no camera misalignment. This was a genuine physical event. The question now was simple but terrifying. How could something moving at 37,000 miles per hour just stop? Within hours, NASA and ESA assembled an emergency panel of physicists and engineers. The discussion was chaotic. Some argued it was a trick of light, an illusion caused by gravitational lensing as the comet passed near the sun. If light had bent around the object, its apparent position might seem frozen for a few moments. But the stillness lasted far too long for that to be true. Others suggested a failure in data relay, perhaps a synchronization error between satellites. Yet every timestamp matched perfectly. The phenomenon was not in the data, it was in space itself. As the debate intensified, the scientific world split into two camps. One side insisted on a natural explanation. Maybe outgassing jets had fired in the opposite direction, countering its momentum. That kind of reaction could theoretically cancel motion for a short period. But to stop completely, the jets would have needed to produce enormous thrust, something no comet could do without tearing itself apart. The other camp believed something deeper was happening. Maybe 3I Atlas had encountered a region of strange physics, a gravitational null zone between the sun's pull and the galaxy's drift. If that were true, it would mean parts of our solar system were not as stable as we thought. Meanwhile, radio observatories detected a faint but consistent signal coming from the object. It wasn't communication, it was background resonance, a rhythmic pulse that repeated every few minutes. At first, scientists dismissed it as interference. But when the same frequency appeared on multiple instruments across the globe, the pattern became impossible to ignore. It was as if the object was vibrating within an invisible field, caught between two opposing forces that canceled each other out. For NASA, the realization was chilling. If natural laws could be paused, even for a few hours, then the framework of motion itself might not be absolute. The agency released a short statement acknowledging anomalous observations, but avoided details. Behind closed doors, researchers admitted they had no model that could explain it. The event had no precedent in the history of astronomy. Some physicists began to wonder if space itself might have ripples or barrier zones where light and gravity interact differently. If 3I Atlas had entered one, then it could have been suspended in a temporary balance of forces. It was a bold theory, but it fit the data better than anything else. By morning, the silence around 3I Atlas had grown heavier. It was not just a frozen comet anymore. It was a mystery rewriting the laws of physics. And as one NASA scientist quietly asked, if this object can stop the universe for a moment, what happens when it starts again? In the days that followed, scientists from every major agency began what they called the physics war. The mystery of 3I Atlas had become more than an astronomical event. It was now a battle of theories, each trying to explain how the universe could stand still. NASA released no official data, but internal leaks hinted at growing tension inside the agency. Everyone wanted to be the first to solve the impossible pause. The first camp focused on traditional explanations. They believed outgassing jets, created when sunlight struck frozen carbon dioxide, might have fired in the opposite direction, canceling the object's momentum. It was the same mechanism that propels normal comets as they pass near the sun. But computer simulations quickly dismissed it. To counter a velocity of 37,000 miles per hour, the jets would have needed to release thousands of tons of gas every second. No evidence of such activity was detected in the object's spectral data. Its coma remained calm, with no trace of violent emissions or heating. The theory collapsed under its own math. Another group turned to magnetism. Spectral analysis from multiple observatories showed faint metallic reflections on the object's surface, suggesting traces of nickel, cobalt, or magnetized silicates. If 3I Atlas had moved into a region where the sun's magnetic field twisted sharply, it might have locked into alignment temporarily. Like a compass caught in a magnetic storm, the object could have been suspended between invisible lines of force. This idea fascinated plasma physicists, but again, the evidence was weak. No solar flare or magnetic surge had been recorded near the event window. A third theory came from gravitational dynamics. Some astronomers proposed that the object had entered a null zone, where the sun's pull and the Milky Way's drift balanced each other. Such regions might act as gravitational dead spots, invisible pockets where movement slows almost to zero. Mathematically, they could exist, but no one had ever observed one before. If 3I Atlas truly found such a pocket, it would be the first direct proof of this phenomenon. Yet not everyone accepted those explanations. A smaller group began to explore possibilities outside standard physics. They questioned whether the object could be reacting to something we didn't yet understand, perhaps electromagnetic feedback or quantum interference within spacetime itself. Some called it pseudoscience, but others argued that dismissing the unknown had never advanced discovery. Every major breakthrough in history began with something that didn't fit the rules. As the arguments raged on, the object itself remained silent. Its light dimmed slightly, then stabilized as if conserving energy. No motion, no collapse, no explosion, just an eerie balance that refused to break. Even skeptics admitted they were witnessing something unprecedented. Behind closed doors, NASA's top analysts worked around the clock, running new models and rechecking every variable. One report suggested the possibility of internal resonance and energy patterns cycling within the object like a stabilizing heartbeat. If true, it meant 3I Atlas wasn't passive. It was regulating itself. The physics war had reached a stalemate. Every theory seemed too small for what they were seeing. The universe had presented a riddle that science couldn't immediately solve. And as data poured in from new telescopes, one question lingered in every mind. If motion could stop, even for a second, what other laws of nature might be waiting to break next? As the silence around 3I Atlas deepened, scientists began to notice something stranger than stillness itself. Thermal sensors from NASA's Deep Space Network showed that the object's temperature was not constant. It rose and fell in precise intervals, almost like breathing. Every 90 minutes, the surface warmed by a few degrees, then cooled again, repeating the same rhythm again and again. No natural comet had ever shown such stable thermal cycles. To many researchers, it was as if the object had developed its own pulse. When the data was verified by independent observatories in Japan and France, disbelief turned to fascination. A pattern that consistently suggested a system of balance, some internal process regulating heat and energy. On infrared images, bright and dark zones appeared across the object's surface, forming in symmetrical patches. The energy wasn't radiating randomly. It seemed to move with purpose. Scientists compared the data to everything from sublimating ice to volcanic vents, but nothing fit. Instead of releasing energy in bursts like normal comets, 3I Atlas appeared to absorb and release it in waves. The more they studied it, the clearer it became that the object was managing its own stability. At NASA's Jet Propulsion Laboratory, analysts proposed a daring hypothesis. They called it feedback stabilization, the idea that internal layers of different materials could generate small electrical currents when exposed to sunlight. Those currents might trigger reactions deep inside, causing the object to cool itself when it got too hot and warm up when it grew too cold. In theory, this could explain the rhythmic thermal pattern like a natural thermostat on an interstellar scale. If true, 3I Atlas might be the first self-regulating body ever found beyond the solar system. The discovery forced scientists to reconsider the line between lifeless matter and active systems. Could something non-biological still display a kind of structural intelligence, acting to preserve its own equilibrium? Some physicists argued that such feedback loops are simply chemistry. Others countered that if the process could sustain itself indefinitely, it blurred the boundary between inert and adaptive. One researcher described it as the closest thing to a heartbeat ever recorded in deep space. Meanwhile, the object's light curve revealed faint flickers that matched the same thermal rhythm. It was not just pulsing with heat, but with light, glowing and dimming as if in sync with its internal state. To the human eye, those fluctuations were invisible, but on high-resolution graphs, the signature was unmistakable, a repeating signal carved into the darkness. By the end of the week, a new consensus began to form. 3I Atlas was not behaving like a rock, nor like a machine. It was something in between, a relic of cosmic engineering or natural evolution far older than Earth itself. If the universe could produce objects that regulate their own energy, what else might it be capable of creating? That question led scientists to the next mystery: what happened when the object finally began to move again? For almost 40 hours, 3I Atlas remained perfectly still. Then, without warning, everything changed. At 2:16 UTC, a faint tremor rippled through its light curve, a subtle flicker that most instruments missed. Minutes later, the object began to move again. Its position shifted by less than a fraction of a degree, but to scientists watching live telemetry, it was enough to send shockwaves through every control room. The interstellar visitor had awakened. At first, the motion was slow and irregular, as if the object was testing its own trajectory. Then, gradually, it picked up speed, gliding forward with a rhythm that didn't match its previous orbit. Instead of resuming its natural hyperbolic path, 3I Atlas veered slightly, moving along a new vector that no simulation could predict. Telescopes around the world synchronized to follow it, and what they saw only deepened the mystery. The glow surrounding the object dimmed noticeably, and its once bright tail faded into near invisibility. It was as if the comet had wrapped itself in a darker shell. Spectral readings soon revealed why. The outer layer had changed composition, now coated with a thin carbon-rich crust, an effect seen only in materials that have undergone extreme heat or radiation. But there had been no flare, no explosion, no nearby energy source to cause it. The object had altered itself. Its surface chemistry had rewritten under unknown conditions, as though it were adapting to something. For NASA scientists, this was the moment that logic started to unravel. As data poured in, patterns emerged that no one could explain. The object's new trajectory placed it in a near-perfect alignment with the ecliptic plane, the same invisible path followed by Earth and other planets. Mathematically, this orientation was almost impossible to occur by chance. It was as if the object had deliberately adjusted its course to match the plane of our solar system. Even the timing of its restart seemed calculated. The moment it began moving again coincided with Earth's rotation, bringing NASA's main antennas directly in line with its signal path. Inside the Jet Propulsion Laboratory, silence filled the room as technicians confirmed the alignment. Someone whispered that it looked intentional. The director refused to comment, but his face said everything. Every screen showed the same image: 3I Atlas drifting quietly, perfectly steady, as if it had chosen to continue its journey on new terms. There was no sign of collapse or decay, only control. Outside NASA, speculation exploded. Some claimed it was responding to observation, reacting to human attention itself. Others dismissed that as coincidence, but deep down, even the skeptics knew this was different. Nothing in known physics explained why an object could stop, change its structure, and then resume motion along a path closer to us. Theories multiplied, but proof remained out of reach. For now, 3I Atlas was moving again, silent, cold, and deliberate. But if it could restart once, could it stop again? That question haunted scientists everywhere, leading to the chilling thought that perhaps this time it wasn't physics deciding the movement. When 3I Atlas began to move again, something changed in how people saw the universe. For scientists, the event wasn't just a cosmic mystery anymore, it had become a message. A moment of silence that spoke louder than anything in space. Every measurement, every flicker of light from the object seemed to hint at purpose, like a pause designed to make us look closer. It was as if the universe had stopped for a brief moment, just to make sure we were paying attention. Across NASA, ESA, and observatories worldwide, researchers debated what that silence had truly meant. Was it a technical anomaly, or had nature itself just revealed a new kind of order, something between chaos and control? In ancient times, astronomers watched the skies for signs from the gods. Today, their instruments were watching a signal from the unknown, and for the first time in generations, the feeling was the same: awe mixed with fear. Because what if 3I Atlas wasn't random at all? What if the stillness had been intentional, a cosmic gesture meant to show that motion itself could think? The philosophical debate grew louder than the scientific one. Some called it a mirror, an event reflecting humanity's own obsession with movement and progress. Others described it as a pause of recognition, the universe catching its breath after billions of years in motion. Every great civilization has myths about gods who stop time, about creation taking a moment to rest before continuing. Now, in the heart of modern science, that myth had replayed itself, only this time it was real. To philosophers, the implications were staggering. If stillness could exist without chaos, maybe rest was not the opposite of motion, but another form of it. The pause of 3I Atlas might have been the universe showing that silence is part of its rhythm, not a break in it. A pattern where everything, even the stars, knows when to move and when to stop. It was a revelation that made scientists rethink what it means for a system to be alive. The public, too, felt the echo of that event. Millions watched NASA's press conferences and online data streams, feeling that something had shifted in human understanding. Social media exploded with theories, some spiritual, others deeply technical. But what united them all was one haunting realization. For the first time, humanity had witnessed the cosmos pause and resume, as if responding to our gaze. People began asking whether observation itself could influence the universe. Could looking at something change how it behaves? Quantum physics had hinted at that before, but never on this scale. In that stillness, 3I Atlas reminded us that the universe is not a machine, but a living system of motion and memory. It pauses, reacts, and continues just like us. And as it drifted deeper into space, one question remained. If the universe truly stopped for us once, what will happen the next time it decides to speak again? In the end, 3I Atlas left behind more than data. It left a question. How could something travel across galaxies, stop in silence, and then move again as if by choice? For NASA, that moment redefined the boundary between discovery and belief. The universe had shown that motion could think and that even silence could speak. No one knows if 3I Atlas will ever return or if it's still out there, watching from the dark. But its brief pause reminded humanity of one truth. We are not just observers of the cosmos, we are part of its story. Would you be ready if it stopped again? Tell us what you think in the comments, and don't forget to subscribe for more mysteries that challenge everything we know about space.